Okay, the thing that's different about this one is we only have a single log and it's set equal to a number. We don't need to compress it. So at this point, we're going to go straight to exponential form. So I've taken my base. I need to bring my exponent over. And we're going to set it to what my class has been calling Fred. Okay. At this point, we simplify and solve. 5 to the third gives us 125 equals x plus 2, and then we solve for x. And we get x equals 123. You always need to check, so let's do that. Do it on your own and then check it with me. And I'm showing that 5 to the third does equal 125. So if you need to pause here and go through the math, do that. And then when you're ready, let's go to the next example. Alright, what's different about this equation is we do have 2 logs on this side, which we have had in the first example, but this time we have another log on the other side of the equal sign. So let's just start with the left side. How do I combine those two? Using our product rule, I'm going to condense it. And we get log base 3 of 9x equals log base 3 of 54. So now let's go ahead, and what I notice here is that I have got a log base 3 and a log base 3. So I have logs of the same base on both sides. If they are equal to each other, these also have to be equal to each other. So we could use one of our exponent, I think it's exponent to log rules. I'm going to do this over here on the side. We could choose our base of 3 and then put our log base 3 of 9 to the x in the exponent and set it equal to, again, 3 raised to the log base 3 of 54. And then what we learned in our lesson was these become 1 and these become 1, and we just end up with 9x equals 54. We could go through all that, but again, we can just see here that if the bases are the same, then the Freds, as my class is calling them, the Freds have to be equal to each other also. So at this point, let's drop the logs and solve this equation, which is x equals 6. Take a moment and check it. And this one's pretty easy since we can condense this log plus log with multiplication. 6 times 9 is 54, and that does match what's on the other side. So if you need to take a moment to pause and check the math and the steps, please do that. And when you're ready, let's go to the next example. Alright, this example is log base 9 of 3x plus 14 minus log base 9 of 5 equals log base 9 of 2x. Now notice we still have 2 logs on this side. This is like the last one, we have a log on this side, on the right side of the equation. The difference here is we have a minus sign. So instead of using the product rule, we're going to use the quotient rule to condense it. Alright, so when we condense that, remember subtraction becomes division, so we end up with log base 9 of 3x plus 14 divided by 5 equals log base 9 of 2x. Again, we are in the situation where we have logs in the same base, so that means our Freds have to be equal to each other. So let's drop the logs. We get 3x plus 14 divided by 5 equals 2x. And now we just simplify. I'm going to multiply both sides by 5. Those 5's cancel out, and I get 3x plus 14. Over here, I get 10x. And now I solve for x. So x equals 2. So take a moment to check it. Hit pause while you do it. And here is the proof that it works. So take a moment, check the math, figure out any questions you might have, and when you're ready, let's go to the next example. Alright, here is our new equation. Log base 4 of x plus 2 times log base 4 of x minus log base 4 of 3 equals log base 4 of 72. Now, the thing that is different about this equation, besides the fact that we have 3 logs on the left side of it, is we have this 2 that is being multiplied by one of the logs, but not the others. Now remember, log is an operation, so we cannot distribute it to the x on the other side of the log. So we've got to think about our rules. We have one called the power rule that allows us to take this whole number in front and make it an exponent. Now why would we do that? Because we cannot do our product rule until we get rid of the 2 out in front. We can only use our product rule if that 2 is an exponent. So let's simplify. Alright, so what that has given us is in the middle, the second term is log base 4 of x squared now. Alright, make sure that you understand how that works. Look back at your rules. Now I can go to the product rule and simplify the first 2. And when I do that, multiplying x times x squared gives me x cubed. So now I have log base 4 of x cubed minus log base 4 of 3 equals log base 4 of 72. Now I can use my quotient rule to simplify the 2 logs on the left that are still there. And when we do that, we end up with log base 4 of x cubed over 3 equals log base 4 of 72. Now at this point, I notice that I have a log in base 4 on the left, and it is equal to a log in base 4 on the right. So if I am taking the same operation, and they're equal to each other, that means my freds have to be equal to each other also. So I can drop the logs and simplify and solve. I'm going to get rid of my denominator. X cubed equals 216, sorry. Take the cubed root of both sides, and x equals 6. Alright, and again, we always have to check, so pause it, check it, and then turn it back on and check against mine. Alright, so there's the proof that it works. Pause it now and go through the math, make sure that you understand it, make sure I followed all the rules correctly. And when you're ready, let's go on to the next example. This will be the last one. This example is log base 3 of x plus 24 minus log base 3 of x plus 2 equals 2. Now the only thing different about this one is that both of our freds are binomials. Okay, so we have a minus, so we are going to follow the quotient rule, because remember, it doesn't matter what the numbers look like, we always follow the process. And the process says in the quotient rule that we rewrite it as division. So let's do that. Alright, so now we need to look at this expression, x plus 24 over x plus 2. Now one of the problems that we have had this year is understanding when we can simplify from top to bottom and when we cannot. Because we have pluses in between our x's and our numbers, we cannot cancel out these x's, and we cannot simplify this 24 over 2. Okay, we have to treat them as